Hello and welcome to Patch Math, where today we are going to patch your math knowledge on using the unit circle to graph trig functions. The reason I'm doing this video is because I keep seeing my students being taught how to memorize the characteristics, which is valid. Even when we're creating this table, there are certain characteristics you are going to need to know, so it's not a complete waste of time. You do need to go over those. But if memorization is your only method, it's going to become difficult to remember the details when a little bit of time has passed. If you know how to use the unit circle, you can recreate those details at any point, just having that one skill. And one skill to recreate a bunch of memorized knowledge is a lot better than a bunch of untethered memorized knowledge. So let's tether that memorized knowledge, those phase shifts, the A, B, C, those transitions on your parent function, to what if we just generated a table and used the unit circle as our calculator to generate that table. Well, notice I've gone ahead and did a little bit of setup here to save us some time, and you're going to see our step 1, 2, 3. They're written out of order, and I did that for a reason. The first thing we're going to want to get used to is the x on your unit circle is not the same x that you have inside your trig function. The y on your unit circle is not the same y you're going to output with your trig function, and differentiate between those is vital here. I say that, and I'm going to go ahead and state I'm going to name all of my x's on the unit circle xu, because those are x's on the unit circle. That's x subscript u. You can name them whatever you want, but don't name them x. Why? Because we have an x that's already set by our trig function. And if you use two x's in the same problem without some sort of subscript or some other, or changing one of them to a different variable, it's technically incorrect. Under that same idea, I'm going to label anything on the unit circle as y sub u. So that way I know the y is not the same y that's being outputted by my sine x. Now, it doesn't really matter for a y if you use f of x over here, because f of x is different than if we define them this way. We know f of x is not y sub u here, or y, the y on the unit circle. So you've got a little bit of flexibility. Just wanted to make sure that's clear. This chart does get a little confusing to students. One of the reasons that I put the x and the f of x side by side in T table is why I just put in the yellow box there. That is what you are actually going to graph. This is what's going to generate your ordered pairs. However, to generate your ordered pairs, we've got to thoughtfully choose our x. And my whiteboard's not working right. Oh well, we want to thoughtfully choose our x, and that's where that little pieces of memorized information about the period, the distance between the max and min, the distance between max, min, and midline, all that stuff comes into play. So I'm going to stop explaining why I'm doing this and then just do it. For choosing my axes, the one thing I know about a basic sine function is it goes through the origin before it's shifted left or right. Now, I did just give you an ordered pair accidentally because we are looking at the parent function here, but I want you to see how that works. So I want to take x, and I'm going to plug it in. Theta. Well, what's our theta here? Theta is always going to be the inside of your trig function. Well, this is going to get a little confusing on this example, but if you watch the next video, it has an example where your theta is not your x, all right? But in this scenario, theta is equal to x. Theta is always going to be whatever is on the inside of your trig function. So there's that little note. So since theta equals x, theta is 0 here. That being said, theta is what we find on the unit circle. Recognize these values here are your thetas. It's angle, the degree. Remember, these are angles we're finding here. Degree of opening. These are angles we're finding here. So our theta is 0. That means we are looking at this line. We have a closed angle at 0. And then we want to find sine using that. So we plug in 0. We know sine are the blue values here. Sine is always your y sub 0 here. All right, always your y sub 0. Or I said that wrong. See, I do that. Y sub u, it is our y sub u here, not y sub 0. I said that 100% wrong, and I'm going to leave that in this clip so that way you can see teachers make mistakes verbally too, and on the whiteboard. You've seen me make a mistake or two if you've been one of my been one of my students in my lessons. So sine of theta is 0 here, so that would mean that this is 0. In this example, we have no shifts. We left or right. Or up and down. We have no dilations that are going to affect anything outside of that. So this also happens to be 0. Our midline is still at the origin. Well, let's keep on keeping on so you can see that pattern a little more clearly. I'm going to go ahead and choose pi over 2 for my x. I take pi over 2. All right, we do know theta equals x here. I did not write that out clearly because it is whatever's on the inside. So we happen to have pi over 2 as well for a theta. Then this one's a little bit different. I'm like, oh, I got to open to pi over 2. Well, where is pi over 2 on the unit circle? It is right here. So we take this angle and we open it all the way to there. When we do that, we know our sine is always our y sub u value. So y sub u here is 1. So sine of pi over 2 is 1. So f of x is 1 here because there is nothing on the outside of that sine function that is going to shift it or dilate it. Most teachers want you to do max, mid, midline, and a full period or 2. I'm going to do max, mid, midline, and a full period. You're going to go ahead and see me move on to pi. I plug in pi. Well, that means this angle opens even more. We have what we call a straight line, 180-degree angle, which is also pi in radians. So I wrote that wrong. You're supposed to start step 1, x equals pi, and then you're like, oh, well, x equals theta, pi, and then I'm going to open this to theta, and then we were like, oh, sine is 0 here, and we have nothing shifting it left or right, so 0. Going to do another, oops. Let's say we do 3 pi over 2. Adding another pi over 2. Well, that means our theta is 3 pi over 2 because theta and x happen to be the same thing here. 3 pi over 2. We're going to go ahead and open that. This now becomes greater than 100. Opens to here. So, oh, I messed up my whiteboard by accidentally deleting the image and I had to fix it. So I think I did part of that off the recording. I moved that arm to 3 pi over 2, arm of the angle, and it opens up there. We will find y sub u to be -1. In this case, y sub u does happen to be f of x, so this is also -1. We have found our max, our min, and some midlines, and we've done almost a full period. We just got to make it back to where we started. Let's go ahead. We know our period is 2 pi here. That is one of those characteristics I would memorize for sine and cosine. That's without a value in front of your x that is super important. That does change if we have translations, and we'll talk about that in the next video. So we will go ahead and plug in 2 pi. Well, 2 pi is for x. X happens to be theta. You're seeing the pattern on this problem. It's not the, it is the same series of steps, but pattern. Pi is not always, or theta is not always x. Well, if we take a full rotation to 2 pi, that means that we end up, notice all the way back here, we went all the way around in a circle. Well, our y sub u is 0. And we are done with our table. Now we've got to graph this thing, and that's all right. Normally, your teachers are going to give you blank graphing paper, and then they are going to ask you, this would be step 5. Step 5, generate the table. Once the table is generated, do the graph. Why I did a voice on that, I do Why I did a voice on that, I do not know. The only thing that you're going to be graphing here are your x and f of x. We're not graphing theta. We're not graphing y sub u. We're not graphing x sub u. Just our x and our f of x. And you don't have to memorize anything other than a few key characteristics here because you use your unit circle to regenerate this. This is still going to go throughout the origin for our midline. We will go ahead and we're going to do pi over 2 as our labels here. And that is because that gives us the most important information. Max, min, midline. All right, this is 0. Go ahead and put this negative pi over 2. Cool deal. So 0, 0. We're now going to graph. I already put that point there in purple. But yeah, 0, 0. Then pi over 2, 1. This is 1, 2, 3. This is negative 1, negative 2, negative 3. So that would give us 1 here. Then pi, 0, midline. 3 pi over 2, negative 1. 2 pi, 0. And now we just kind of sketch our graph through those points. Now this is a solid line, and the reason you're seeing me sketch it this way now, because the graphs are weird on these, go ahead and put this in there. We have this. So this would normally be a dot. Oh, darn it. This would normally be a solid line. I'll go ahead and make it solid now. This curves up a little bit more here. And that is a good sketch of sine of x. That should be a little more rounded out there. And go from there. All right, and once I fix the arrows on this, you have just graphed sine of x by using the unit circle to find your f of x values. All right, thank you so much for your time.